Welcome back. Previously, we were dealing with how to find the log and anti-log of a certain number. The module we are dealing with is interest and time value, where there is no computation of log and anti-log directly, but you need to do the log table as well as anti-log table analysis during the computation of an interest. Basically, in compound interest scenario, so you need to be very cautious regarding how to find the log and anti-log of a certain number. Let's deal with some of the further cases that comes under compound interest where you need to use log as well as anti-log functions. Next case, in what time will a sum of rupees 1234 amount to rupees 5678 at 8% per annum compound interest payable quarterly? Okay, in this question you need to find the time, and the amount of 1234 is converted into 5678. So this one is the principal amount and this one is the annual amount. Rate of interest is 8% and it is payable quarterly. Remember, whenever the question comes where the payment is or the rate is based on quarterly basis, you need to consider the rate and n accordingly. So here A is annual amount is 5678, principal amount is 1234, R is 8%. Since it is a quarterly payment, you need to divide by 4, you will get 2, and n we don't know. Since it is a payment, its payment is based on quarterly basis, we can write that n be 4n, because if you know the value of n, you could have multiplied it with 4. Since you don't know the value of n, you can multiply it with n, so it will be 4n because it is a quarterly basis concept. That's why we are using 4n. Next, let's substitute the values in the equation. The equation is a equal to p into 1 plus r by 100 raised to n. Actually it is n. I just substituted the value of n as 4n. So here a is 5678, p is 1234 into 1 plus r is 2 here divided by 100 raised to 4n. By solving that, you will get 5678 equal to 1234 into 1.02. By solving this part, you will get 1.02 raised to 4n. And finally, it will be 5678 divided by 1234 equal to 1.02 raised to 4n. From this part onwards, we need to use the functions of log concept, because here the unknown part is the 4n, which is a superscript of a value. So you need to change its position. In order to change this position, you will multiply both sides with log. So you will get here 5678 divided by 1234, you will get 4.6013, and the right hand side of that equation remains the same. So you multiply both sides with log, you will get log 4.6013 equal to, you change its position 4n log 1.02, where from now on you need to use the log table and find the value of log of 4.6013 and log of 1.02. For the time being, I am giving the answer. You need to be aware about how to find the log of certain numbers. Log of 4.6013 is 0.6629 and log of 1.02 is 0.0086. By substituting those values in the equation, it will be 0.6629 equal to 4n into 0.0086. So by using the basic mathematical step, the unknown numbers is shifted to the left hand side and known value is shifted to the right hand side. So 0.6629 divided by 0.0086. Finally, n equal to 0.6629 divided by 4 into 0.0086. I hope you understand why we did like that, because here for 4n we shift the 4 to the right hand side of the equal sign. When a number shifted to the other side, since it is a multiplication case, it will become 1 by 4. So 0.6629 divided by 4 into 0.0086. Finally you will get 19.27. So the time taken to change this amount to this for an 8% interest which has been paid quarterly is the 19.27 years. So just go through it. The concept is simple. The only part is you need to think properly where to use the log and when to use the log and how to use the log. Okay, just go through it. If you have any doubts, just contact me. Let's deal with some of the cases relating to compound interest. Next one. A man borrowed a certain amount of money at 12% compound interest per annum and cleared the debt by paying rupees 9408 at the end of 2 years. Find the sum borrowed. Okay, a man borrowed certain sum of money and repaid back within 2 years. And the amount was repaid amount was 9408. Interest rate was 12%. You are asked to find the principal amount or the initial amount. So let's extract the details available in the question. Here A is annual amount is 9408 and number of years is 2, R is 12, P is, we don't know, you need to find the value of P. By substituting in the equation A equal to P into 1 plus R by 100 raised to N. Here A is 9408 equal to P into 1 plus R is 12 divided by 100 raised to N is 2. So you will get 9408 equal to P into 1 plus 0.12. Here 12 divided by 100 you will get 0.12 raised to 2, which can be again written as P into 1.12 raised to 2. You can either take the square of this number from this point or you can take the square of this number at the end, towards the end. Okay. So P equal to 9408 divided by 1.12 raised to 2. So P equal to 9408 divided by 1.2544. That is the square of 1.12. Finally, P is 7500. So you may come across questions like where the computation will be similar and simple. But depending upon the nature of the question, you need to sometimes use log functions or sometimes use anti-log functions. It depends upon the nature of question. There is no rule regarding which type of question requires log table or in which type of question requires anti-log table. That depends upon the nature of question. But from my suggestion is that means it's a simple trick. It's not a universally accepted trick. My suggestion is that whenever you are asked to find n in a compound interest concept, whenever you are asked to find n, in that question there will be either log or anti-log. Surely there will be a log case, and depending upon the nature of question there will be anti-log. That depends upon the nature. But remember, whenever you are asked to find the time, it is a case of log or an anti-log. And never consider it as a universal rule. It is just a trick for your examination purpose. Okay, just go through these two questions and make familiarized with various cases. That's all for today. We will discuss about the further cases in the coming sessions. Thank you.